Thanks, folks. Hey, good to be with you all. Hopefully we'll have connectivity the whole time here. But if not, I'm going to put in the chat box that Dr. McKinster can tell you about and show you. But I'm going to put in there the whole presentation for today, okay? So that way you can look at this and explore the links and the resources that I've got there on this presentation at your own time, especially if you're like me and you have no social life. This evening, you'll be digging into some of these citizen science resources, okay? Anyway, I really salute you all for taking a citizen science class. This is a really relevant, important topic that you're embarking on. And you're going to encounter, as I'm sure Professor McKinster has talked about, citizen science no matter what field you all go into. You know, sure, I'm in geography and GIS, but if you go into health or business, planning, so many other fields, you're going to be encountering data from crowdsourcing / citizen scientists, and you'll also probably be involved with projects that generate it for a variety of reasons, right? One being it's a valid source of data. Two, as we'll talk about today, you can map and analyze that data quite easily nowadays with some bumps along the road. And number three, oftentimes organizations, nonprofits, government agencies, private industry, they don't have enough funds for dedicated funded field staff, right? So they rely on citizen scientists to conduct some of the research and the data gathering that they need. Okay, so there's a variety of reasons why I think that this is important. Let me just illustrate one project that I think that you might want to even do this semester. And Professor McKinster and I briefly talked about it in the session before you all showed up. But let me give you my contact information right here. I am definitely available. I mean, just ask your professor. I am one of the people that say, please contact me, and I actually do respond, okay? So please get a hold of me if there's any way that I can be of help to you in your future journey. I think it's important for you all as students to develop that professional network even now before you graduate. As you know, it is connections that will help you in your journey. And I don't mean the 80s band journey. You guys with me? I mean your professional journey after graduation. Okay, so start developing that network now. And again, I hope to be in your network. So feel free to connect with me on LinkedIn or any other means. Don't punish yourself by looking at that video channel of mine, but if there's some career tips on there that are useful, then please do. So what we're going to do today is we're going to talk about the linkages between citizen science and mapping and hopefully build on the things that you've been doing thus far this semester. Also, figure out, what topics can I teach? Can I do research on? Can I participate in using citizen science, using maps and real-world projects and tools and data? But then also, how can I communicate my results of citizen science and other topics using what we call web mapping applications that I know you're just getting into? So this is a music professor. So if the point of this slide is just to illustrate that anybody can use mapping tools. It's no longer just the planners, the geographers, the environmental scientists, right? We've got people in business and sociology and engineering, language arts, and other fields using these tools, in part because they're so much easier to use than before. Back when Professor McKinster and I started with GIS, or Geographic Information Systems, it was rather clunky. Required a lot of specialized hardware and setting up the data sets and so on. And not to sugarcoat it, not to say that it's all easy now and it's all at the touch of a button, because it is a science, geographic information science. And because of that, we can't just say, well, one click and you're off and running. No, there's some things that need to be understood and taught and learned, but it's vastly easier than it ever was in the past to use these tools. So again, folks, I salute what you're doing. Maps have always been powerful means of communication, so nothing new now than in the past in that sense. But today's maps, as you know, are digital, they're dynamic, they can incorporate real-time data, 2D, 3D, and they can be embedded into communication tools like this story map that this person is actually showing right there. Now, why maps for citizen science? Well, as you know, citizen science data is collected somewhere, right, in the field. and it often exists in context and in content with other kinds of information that we'll talk about here this class period. And then you can look at the patterns that result, right? So what I mean by that is the point is not to put dots on a map, okay? That is just one of many steps. You're not just putting points on a map. You're analyzing. That's the whole reason to do it. You don't want to add the mapping component if all you're doing is putting these dots on a map and symbolizing those dots in different colors. No, what you want to do is look at the patterns, the relationships, the trends. Are the north-facing slopes different in terms of vegetation than the south-facing slopes? Is there a certain zone in my city where trees seem to be more maybe stunted than in other places? Maybe they've got some sort of ash borer disease or something like that. Is there a certain location on this set of streams where the water quality, dissolved oxygen, is lower? Those sorts of things. And why do those patterns exist? That's what we want to do. Now, you've all seen a map like this, right? You've probably seen this on a daily basis when you're looking at traffic patterns to get to campus, for example, or on break when you're navigating in another city. So this is generated with citizen science data, as you probably are aware, right? There's not a ribbon across the highway every few hundred meters to detect the vehicle count. It's all generated with phones, right? So when you're using your location-based services on your phone and you're using, let's say, Google Maps in this case, your information is being fed to the cloud, the Google Cloud, and that information about, there are 10,000 phones moving across I-10 in downtown Los Angeles, and they're all going at 15 miles an hour. That we're going to symbolize that segment of the road red, right? So that's what's generating a large part of what we actually take for granted now as data feeds on a daily basis. So I just wanted to point that out, that sometimes the citizen science data that you're generating, you're not even aware that you're generating it. But there you go. That's a perfect example. Now, citizen scientists, and this is one of the reasons why I have such great respect for your professor. He was on board with citizen science before most of the rest of us actually started talking about this. So some of you probably know birders, right? Birders, people that are interested in birds, have been doing this for what, Professor McKinster, 140, 150 years, late 1800s. So the birding community has always been active in citizen science. What species was the bird? What time of year? What time of day? What's the tree species? What does that bird sound like, etc. But now these other topics that citizen scientists are collecting data on can be used in different subject matters, in different disciplines on the university campus and beyond. And then again, mapping the data is the reason why we do it, is to lend new understandings and insights. So why teach and learn with these tools? Well, it's problem-based learning. So that's exactly why you're taking this course, right? You want to actually dig into some of these real-world issues of our 21st century world. And this number one here, to me, sort of encapsulates why we're doing this. Why is this important? Well, because these issues are important, right? We're not just making this up for the classroom. So for those of you that think, there's some courses that I've taken in my academic career that maybe aren't the most relevant, but the one you're taking right now with Professor McKinster, that is incredibly relevant because you're digging into all these key issues of our time. And these issues are becoming more complex, as you know, and they're also affecting our everyday lives. We're also using scientific and geographic inquiry when we use citizen science and GIS tools. We're asking questions, we're gathering data, we're figuring out what data to analyze, what data to throw away, right? Because we're in this big data world nowadays, right, folks? There's a lot of information out there. Let's just take ArcGIS Online. ArcGIS Online is a web-based mapping platform. There's tons of data there. There's something like thousands, 2,000 or 3,000 maps that get generated on ArcGIS Online daily, okay? So that means just like the general web, there's a lot of good information. There's a lot of information that's not good. There's a lot of information that looks good, but you can't tell what the source is, so you don't know what the data quality is, and so on. So we're using that to assess the data quality. We're looking at results. We're analyzing it using some spatial analysis and other tools. We're asking questions, and that leads to more inquiry. So it's really asking questions about the world and trying to understand our world. and also to make the world a better place. I mean, that sounds maybe corny, but that's a lot of what GIS research is all about, is making cities healthier, making them more sustainable, making agriculture more sustainable, food security, mitigating the effects of natural hazards. It's all about improving our world, making it a healthier, happier, more sustainable place. And then, so if you students out there, if you're really interested in making a positive difference on our planet, which I hope you are, I'm sure you are, otherwise you wouldn't be taking this course, then really investigating these tools and these data sets, I think, are going to be very helpful for you in the long run. Also, if you like getting outside and you're in a beautiful part of the world, as Professor McKinster said, I've been to your campus 2 or 3 times in the past, and I've also been through your area in not too distant past. Also, I was down at Cornell about 2 years ago. So I love your part of the world. If you like getting outside, all of what we're talking about today will help you do that, and also have a job doing it, which is great. And also you're doing some meaningful work. Now, here's a sad kid. Why is this kid sad? Well, because without geotechnologies, there would be no supply chain management. There would be no, what do I mean by that? The assembly of all of the parts that goes into making a phone or a computer or anything else that you enjoy having around. That is all based on GIS. There would be no Uber. There would be no geocaching and fun stuff on the landscape. There would be no web mapping or directions to your favorite coffee shop. You know, it would be sad. So geotechnologies is powering all those things. Now, this data right here, and you could go to arcgis.com and actually pull up this data, which is what I'm doing here. This is OpenStreetMap. And OpenStreetMap is one of the big success stories with Citizen Science, because OpenStreetMap allows us to generate street data and trails and alleyways and other things on the landscape. It was originally thought of in countries where there was no national mapping agency, or countries where there was a national mapping agency, but that data was not releasable to the general public. So instead of waiting around for 100 more years until, you know, that mapping agency was actually able to generate and then share that data, ordinary citizens said, we're going to build a street network, global, and it's going to be citizen science data, so generated by citizens. And so here, you know, you can zoom into OpenStreetMap and see the very detailed information that exists inside OSM. So OSM is like the Wikipedia for street networks, and very detailed data. You can even see the lot lines in this part of the Netherlands in this particular, and the addresses for the OpenStreetMap. So OpenStreetMap is one of the, I think, shining examples of real-world citizen science. Now, there's all kinds of citizen science projects out there. Globe at Night is one of the ones that we at ESRI have been involved with for years. It's what stars can I see at night? So there's this whole concern about, you know, we're gradually increasing the lighting around the planet, and therefore we're actually seeing stars a bit less. So this is a fun but interesting and important way of getting people out on the landscape at night to say, okay, based on this set of diagrams, what is your city? Is it a 3 in terms of being able to see things? Is it a 4? What amount of stars can you actually see? And therefore, what's the light pollution? Things like identifying storms. I mean, this is very relevant this fall, as we've encountered so many hurricanes just in the southeast U.S. and in the Caribbean, right? So let me just show you one of the citizen science projects that was actually set up about 9 days ago, and that is out here. And I'm going to paste this URL into the chat box. Are you guys seeing the chat box over there?
Oh, I had it turned off. I can pull it back up.
No worries, because you can always share this with the students after class. But this is a Hurricane Maria interpretation tool. So basically, you know the severity of the storm. This is a pre-hurricane image of night lights in Puerto Rico, and this is a post-Hurricane Maria. So this is a very serious and grim sort of thing that happened, right? I think a lot of people don't realize the extent of the damage. And the folks on the ground, the disaster mitigation people from nonprofit agencies, government agencies, and private companies are trying to assess the damage that the hurricane caused there. So what we did here at Esri is we actually set up this Maria interpretation tool inside ArcGIS Online. And what it does is you can see the points, all of these dots are citizen science collected information. So we talked about, actually before you folks arrived, let's say I zoom into a certain area, actually having you do some of this later this semester.
I think we're actually going to do it on Monday.
Oh, very cool. Yeah, so I mean, it's grim stuff, folks, but the idea is we're going to look at, let's compare pre and post. So you can see the pre-hurricane image, satellite image on the left side. The post is on the right. So since it's post, it was not corrected for cloud cover, so you might see some areas that are shadowed with clouds. And but the idea is we're going to go in to, let's say, this area right here. And I'm actually inside ArcGIS Online. You'll have to join the group and you'll have to sign in to an ArcGIS Online account. But you can see here, just looking at the trees on the left side, which is the pre, and now look at the post. You can see a lot of those trees have been flattened. And so you can see these huge trunks of the trees. So now I'm going to look at this particular, there's a new house that was built, or a new structure that was built before or after the original imagery was taken. But I'm just going to look over here, and I can see some of these roofs were damaged in this area. So in this case, I'm going to click on the left side and go damage observed, and I'm going to click on this house. I can put some comments in here if I want to, but I'm signed in as JJ Kursky here, so that it's got an edit tag on it. And then I'm going to go over to this particular housing unit and look at that, and I can see that it doesn't look like there's any damage, so I'm going to put no apparent damage on that structure. So does that make sense? What we're doing is mapping the damage that is observed from these satellite images for thousands and thousands of these structures. And there's nobody on the ground that can do this in quite the same way that this is being done by these citizen scientists. Okay, so that's something that you can actually contribute to right now, and it's going to be live for several more weeks, and it actually can help people. Okay, that's the nice thing about these. So this is the Hurricane Maria mapping and assessment tool. And if I zoom out again, I'm going to see once more thousands of points that have already been collected. But as you can see, just from our simple example here today, the ones I did were just these two right up in this area. There's lots and lots of territory that still needs to be assessed. Okay, so we need your help, and it would be an interesting project, but also I think an important one. All right, so let's go back to what we were talking about, different citizen science projects. This is not the way to do it. Sleeping dogs I saw in Taiwan. So I'm walking by these dogs all sleeping soundly in the morning. But if you're teaching these topics someday, I think the important point is don't teach them in a way that puts people to sleep, right? Hopefully I'm not putting you all to sleep. Are you all awake? Everybody good? Okay, super. I'm seeing you right there in the webcam. Cool. Now here's some methods of mapping your own data via crowdsourcing. I'd like to actually get into the practicalities of not only how did that Hurricane Maria data service get set up, but how can you actually map this? How can you map your own data via crowdsourcing? So here are just 6 ways. First of all, if you think about creating an editable spreadsheet and collecting it into data into it and then post it up in ArcGIS Online. So what you do there is you've got a spreadsheet of data, okay? You have, let's say, latitude, longitudes, or street addresses, or city-country combinations. What you do is you create a spreadsheet on your own local device, your tablet or your laptop, right? You put it up into ArcGIS Online. You actually make a data service, and this might sound a little GIS geeky stuff, but it's actually pretty easy, and if we have time, I'll demonstrate it. But once you create that data service in ArcGIS Online, what you do is you say, make it editable, okay? Make it editable. And once you do that, you can say, I want ordinary folks to be able to log, to actually contribute data to it. And I want them to, now you've got the ability to either have them add more data, or you can also give them the ability of editing other people's data. So depending on your project, that may be something that you might be interested in doing. Why would I want to just have them add? Well, let's say I want to have my people out in the field or on their laptops or tablets inside a laboratory or classroom setting add data to a project. Maybe I don't want them to edit other people's. Maybe I do. So in my case, back on the Hurricane Maria, if I go to a point that someone else had edited, so let's go down to this area here. And here's a point. I'm going to zoom into this point. And it says damage observed. And it was edited by whoever 753544 user is. So I'm going to go and look at the pre and post. I agree with that. But let's say I didn't agree with that. See, this particular tool was set up in such a way that I can actually edit someone else's work. Does that make sense? You know, I can change it to, no, you know what? That's completely destroyed. So I can overwrite what someone else has done. For other projects, let me give you a real simple example. How many of you have ever taken a MOOC, a massive open online course? Has anybody taken a MOOC? You might want to do that at some point. There's some, if you're really interested in geographic information systems, which I hope you are, Esri, we've got a couple of very high quality MOOCs out there. One on cartography that's starting in the winter, so you know how to make effective maps. We've got one on spatial analysis. We've got one on coding. So those of you that are interested in what's actually behind the scenes in these mapping tools, how do I set one of these up where I have this sort of pre and post comparison? How do I do that? So we've got one on setting up these web mapping applications. Anyway, we've got about 5 or so. And I've also worked with Penn State in the past to set up their massive open online courses. Anyway, the point is that there are certain ways that we can get students interested in participating in such a course. So one of the things I've done in most of those MOOCs is the very first week, I actually had them add their hometown to or where they're located right now, to a Citizen Science crowdsourced ArcGIS online map. And in that particular case, I actually did not give them the capability of editing each other's data, okay? So all they could do was add a point. They couldn't delete or change anybody else's, okay? So that's why I set it up the way I did. I just wanted them to be able to add their own and keep it really simple. Now, over time, I used it as a teaching tool throughout the MOOC. I went back to it, for example, a week later, and I said, why couldn't you add anybody else's point? And what are the pros and cons of editing other people's data? Also, a few weeks later, added another segment to the conversation, and that is location privacy. So they added their own location to that crowdsourced map. And I said, is there any sort of compromise on your location privacy? Is there any sort of concern that would arise from you adding where you are right now? I mean, did you put it on your apartment building, on your house, or did you just kind of put it in the city where you live? And if you did put it on your apartment building or house, does it matter? Does it matter if I know that student 100 actually lives in Jakarta or wherever, okay? So then we had this nice discussion about location privacy. Anyway, the point is that you can set up these services so that you can either edit or not edit other people's data. And it's all done through this ArcGIS Online set of attributes on your data. So you can establish whether you want other people to be able to edit other people's work. But the idea there is you create a spreadsheet like in Excel or just in Notepad or any sort of text editor. You push it up into ArcGIS Online and you make it editable, and then other people can add data to it with the fields that you defined, right? If you said, I'm going to have one on water quality, so I'm going to set up fields. It's going to be dissolved oxygen, it's going to be conductivity, and it's going to be pH. Those 3 things. They can't add other things outside the boundaries of what you established. So they're still following your own table structure. but they can then go to a map and add their own data to it. So that's probably the easiest way to set up one of these things, is to create a spreadsheet, make it editable, and then add data to it. There's also something called Snap to Map, where you can actually create a story map. A story map is a multimedia map. Have you made story maps yet?
Not in any detail. They've seen a couple, but.
Okay, cool. Yeah, it might be something to look into in further detail even after the course ends, because think about your research there at HWS. You've got a whole wide variety of courses that you are taking, that you will take, some of which might be really good to present to your colleagues, peers, and also your professors with a story map as part or all of the presentation. So here's just a simple story map I made at the University of Denver, which is actually where I teach. And I made a simple story map of the university campus. So it's basically photographs and my little walking trail around the campus. You can crowdsource these story maps. So for example, if I go to this one, here is a story map that I set up in crowdsourcing mode. It's a tree survey. So if I look at this map, I can see that other people, not just me, but other people have actually added trees to this and other plants to this map. So this isn't anything I did. This is data that other people contributed to, okay? So how did that happen? Basically, you go to the story mapping resource, you say, I want to create a crowdsource tree map or litter or water quality or whatever you want, and it creates the template. It may look like there's a lot of coding involved in creating one of these things, but really these templates that, or web apps is what they are, that you can establish, for example, in the story maps zone, is really quite easy. So you could do this on business types in your community. You could do this on litter. You can do this on dangerous intersections. I'm a big walker, which is why I was walking down the street of your town that wintry evening a couple years ago. But I'm very interested in looking at, walkability of communities. So I notice things like, if a sidewalk ends, or if it's not plowed, or if it's not maintained, or there's no sidewalk, or, exactly what the pedestrian friendliness is of cities. So I might want to make a story map that I invite people in that community to participate in terms of which streets are walkable, which ones have concerns, okay? So this is another way of setting up your own citizen science collected data. It's simply with a story map template or application that asks people to participate in. Now, in this case, as you can see here, it's fairly simple. It's basically a tree species, but then you've got diameter, height, deciduous or coniferous, et cetera, and then condition. And as you saw from that other one, another point that probably should be made here today in this class is, how do we assess the quality of the data, right? That's really important. There's all kinds of spatial data sitting out online. ArcGIS Online is one platform of many. But how do we assess the quality of that data? And I hope you students are thinking about, it's great that we have all these data sets available now, but how do we know if they're any good? Well, that's a whole separate discussion. But in brief, the person setting up the service, for example, if I set up this tree mapping one, which I didn't, but if I did, I have the ability of rejecting or accepting each one of these, okay? So as you saw probably in that previous screen, there's a couple of things on there that actually weren't trees. Yep, you may have seen that on the previous slide. But there are many that are, but there are some data points that I might want to throw out when I actually, like there's this thing called test. That's a flower, okay? But there are some things on here that I might want to discard. Maybe they're in the wrong location, or maybe they're offensive, or they have nothing to do with, that one right there, it looks like a bunch of icebergs. And surely that's not in downtown San Diego, right? So the point is that I have the ability of tossing, like this one that says test. I probably should get rid of that if I'm the author of this map. So you have the ability as the author of one of these things to keep or toss the data, okay, or revise the data. You could send out another survey crew, for example. So you've got a lot of power here, I hope, is what you're getting at, or what you're getting from this. So this big participate button, that's the one that indicates whether it's live or not. As you saw from the one that I just opened up, right now there's no participate. In other words, the author of the map has closed the input right now. So I cannot add any data to it. If I could, I would see some sort of button that says participate in this mapping service right now, okay? So as the author of the map, you have the ability of turning on or turning off that participation. All right, another tool that I wanted to at least introduce you to is something called Survey123. Survey123 is how many of you have ever used SurveyMonkey or Google Forms or something like that to either set up a survey or participate in? Okay, most of you. So you know that it's just a matter of dragging items from a web-based form over into your survey form, right? Do you want multiple choice? Do you want true, false? Do you want free text? What exactly do you want to have in each one of these questions? Well, Survey123 is very similar to that. In fact, it lets you create one of these surveys in two ways. So here's an example of what it looks like when you're actually looking at it on the phone. You can use the web forms to set it up, or you can use Excel. And Excel gives you a bit of more power, so you can do branching sorts of things, like if I answer, let's say I want to say living or non-living. If it's living, if that object on the ground is living, then I want to give the user a choice of tree, plant, ground cover, etc. If it's non-living, I want to give them a choice of light pole, rubbish bin. I was just in Australia, so I'm saying rubbish bin, trash can, you know what I mean? I've got non-living things. So depending on how they answer certain questions, you can branch them. You can give them choices. You can do some additional things that you can in Excel. With the web-based form, it's easier, but you've got a bit of a limited options. But they're both valid ways of creating a survey. And the nice thing, kind of circling around to what we talked about a moment ago, the objective always, folks, is to analyze spatially the data. If you didn't care about analyzing it spatially, like the light poles or the tree species or the litter or whatever it is, water quality, then you don't even need to use Survey123 because you don't really care about a map and mapping analysis and the where question. But if you do care about those things, then you want to go beyond, a Google form or a SurveyMonkey. You actually want to map it and analyze it. And the nice thing, again, is that the results of your survey from Survey123 actually gets put up into the ArcGIS Online cloud, the same cloud that we've been looking at all day long in our class here today. That same cloud where for example, Hurricane Maria content is stored is the platform that you can use to analyze. So there's some analytical tools in there. For example, you can overlay, you can buffer, you can run some spatial statistics and other things, okay? So that's Survey123. Now, there's another related tool called Collector. It also lets you use a smartphone or tablet out in the field, just like Survey123 does. And you can also use it in connected or disconnected mode. So let's say you're out in the middle of, rainforest Costa Rica. You might not have connectivity. And so you might want to create it in such a way that allows you the capability of, for the next 2 hours, I'm going to be out in the field. I'm not going to have any connectivity. So basically what it does is it downloads a little piece of the Earth's surface where you're going to be collecting data. And then what it does is it allows you to go out in the field and collect data offline. Yep. And then when you're back into Wi-Fi connectivity, you can sync your data on your local device to the cloud. Does that make sense? So that you can actually collect offline. Really critical in many parts of the world. Okay, so that's Collector. The difference between Collector and Survey123 is largely that you need to go into desktop GIS to actually set up your Collector, what we call domains and subtypes, which allows you the capability when you're out in the field of having the drop-down choices on your survey. You know how when you're out in the field, you want to be doing as little typing as possible, right? Because of sun glare, because you might misspell some things, etc. So you want to have as many of the things that are autofill as possible and as many things as you can select from a drop-down menu as possible. So that's the advantage of these drop-downs, is that when you're out in the field, you've got more data integrity because your users are, if it's a coniferous, you give them a choice of pine or spruce, let's say. and they're not misspelling spruce, right? Because when in the final data set, if they misspelled spruce, the database is going to think, well, SPRUCE is different from SPURCE, right? The misspelling. It's going to be a different species. You know they're the same, but the computer doesn't. So you want to be able to have the users select from menus as much as possible. But they're both valid tools. Here is an example of crowdsourced data that I had a group of educators go out and collect. So this is my live web map. This is out in a section of Redlands, California, and I had them collect, as you can see from the legend on the left side here, landmarks, curbs, trees, buildings, sidewalks, streetlights, etc. I divided them up into zones, so I had a group of educators go out into zone 1, zone 2, zone 3, and so on. And you can see that in this case, someone collected a broadleaf tree. Here's the height and diameter, etc., the species, and then also the ability of grabbing a photo and taking a photo at that location. And this is Southern California, so you've got some interesting tree species down there. But does that make sense? So this is inside ArcGIS Online, and over the course of about 90 minutes, we collected about 1,000 trees. This is with about 100 educators collecting the data. So about 1,000 trees / light poles / porches, curbs, etc. Okay, these light poles are interesting. Yeah.
I just wanted to point out to them, so ArcGIS Online is what you were using for both of the bird investigations, right? The activities we did in class.
Yes.
So that interface is the same thing we're showing you now.
Yeah, exactly. So this map, I've got it embedded in my presentation. ArcGIS Online allows you to use the embed code that you probably have seen in other tools. So you just paste the embed code into a presentation tool like I'm using right here online. So now I've got the ability of having my live ArcGIS Online map inside here. But if I wanted to, I could open it up in, I'm hoping are you seeing this blank window here?
Yep.
Okay, so now it's actually inside the native ArcGIS Online interface, and now I've got one district that can't be drawn. But now I've got that same data set. Now it's inside ArcGIS Online. I just had it embedded in my presentation, but it's exactly the same data. So yeah, so now I can change the base map if I want to imagery with labels, for example, and then I can zoom in and I can see exactly where I collected that information. I might want to go over here to content and turn off these zones. And now you can see that, okay, we've got a lot of historical light poles in that area. These are something that is a historical landmark. It's one of those, sort of late 19th century, early 20th century kinds of light poles. Let's go ahead and look at one of these, show you what it looks like. Oh, that's not one of them. That's a, that's a modern one. But anyway, the point is that you've got a lot of capability here inside ArcGIS Online to do citizen science, as well as analysis. So again, that the spatial statistics, the other kinds of analysis tools are all right inside there. And sixth and finally, I just wanted to say that, this platform actually incorporates other tools, one of which is iNaturalist. It's a citizen science network. It's also a tool that you can use on a phone, and you can gather data with this tool called iNaturalist. The nice thing about it is that if you're out there in the field using iNaturalist and you're using, I don't know, tree species, let's say, and you say, well, this is a spruce. It'll say, well, what kind of spruce is it? Is it a blue spruce, etc.? And it'll show you a photograph of those species that match your description. And so you can select based on the photograph on your phone using the app of what species it is. I know there's a lot of similar kinds of things for birds and other things, clouds, etc. But iNaturalist is a tool that was developed outside of Esri. But the nice thing about this platform that we've been talking about, ArcGIS Online, is that you can incorporate other tools into it. So I've got a essay right there linked with how to bring in that data into ArcGIS Online. Yep. So it's all good. Let's look at some soil data. So here I've got some citizen science soil collected data in a field. So I've got different attributes that I've collected out there and that people collected out there. So if I look at the table, I can see that, okay, I've got some pH, I've got some soil chemistry, I've got magnesium, sodium, phosphorus, etc., data in this field. And I can change what I'm mapping. Let's say I want size, but I don't want lead this time. I want some different attributes. So let's say I want to look at the magnesium. Now I've got lead divided by magnesium. That doesn't make any sense. So let's go ahead and not go to this. Let's go ahead and go to, how about change it right here to one of these other attributes. You see, I'm just mapping different attributes here. Okay, super. Now I've got magnesium, and I can map it by size. I can map it by color. I can even make a heat map. So more magnesium, I've got that hotter color, okay? And I can say done. And I can change the base map, of course, just like I did before, so you can see the extent of this is really pretty small. It's just a couple of fields. Okay, but that's now inside ArcGIS Online. And you can see that there's a G part, which is the map. The I part of GIS is the table of data behind the map. And the S part links them together. So if I go to my table and I go to this particular data point, and then I can center on what I've selected, then that is what I've got selected right now. Now I'm going to change it off of heat map because I don't want it to be, I want us to be able to find that exact feature. So let's say I go to my table again, center on selection, and then I can zoom into that selected data point, which is this one outlined in cyan right here. It's kind of out by itself. So I've got the ability then of looking at data. Again, this is a table of data that's being mapped. How do I map it? Well, in this case, I've got a northing and an easting. It's basically another kind of system like a latitude, longitude. It's just a different set of kinds of coordinates. But I could do street addresses, I could do city, country combinations, etc. So that's inside ArcGIS Online. All right, so this is a shot of the iNaturalist data. Yes.
Can I reiterate something with them? Can you go back to that example with the table?
Oh, sure.
Yeah. So, and we talked about it briefly, but if you think about, right, the ways in which we've talked about maps can be used visually, and then you can start to write equations and operations to ask questions of those maps, and then you can also get really neat ways neck deep into computer programming and doing things with those maps and looking at the ways in which different data sets interrelate. And that's because, right, so many of the data sets are based on tables. So you have tabular data that you can start to ask questions about the relationships of those data, and in many senses you're asking questions about the relationships of those tables of data, right? And so it can be both, extremely visual, but it can also be extraordinarily quantitative. Do you have any ideas of what's one of the biggest data sets you've ever seen, Joseph? Turns out, I'm just thinking about how big some of these tables can be.
Oh gosh. In a desktop GIS, millions and millions of points. When you're online, you have to kind of be sensitive to the web browser and that you're slinging around lots of data points. So generally inside the ArcGIS Online, you're not slinging around or tackling or analyzing millions of points, but definitely tens of thousands. I mean, that Mitch data, we've got tens of thousands of points, or not Mitch, Maria data, where we've got tens of thousands of points already in there. And you can see that there are various ways of sort of optimizing your web experience so that you maybe cluster the data as you're zoomed out, so you're not viewing every single one of those in the web browser.
Yeah, great, thank you. We have till about 9:35, 9:40, somewhere in there.
All right, so we're in our last few minutes. I want to leave some time for questions here too, but let's come around to some of the points I mentioned at the beginning, and also something that Professor McKinster just mentioned, and that is you don't want to just map it, right? You don't want to just have a bunch of points floating in a field in your map. You want to analyze it. So in that case, do I have? Let's look at pH. Do I have any sort of pattern to the pH? So if I'm going to map pH with, how about color? Yep. So the darker is going to be the higher pH. Do I have any sort of pattern? Maybe, maybe not. But let's just go see in there. So pH by how about size? That might give us a good indication. And then I've got options too. So let's say I want to classify my data and I want to use quantile, which the same number of observations in every class. So the way that you classify and the way you symbolize data is very important also. Now I'm going to look at, here's my pH. I don't really detect any sort of clustering or spatial pattern, although I do see a couple of areas like right out here where I'm pointing with my mouse that has a higher pH than other places. There's a couple of other higher values too. It seems to be a bit lower out here to the northeast, but there's a scattering of high pH values just about everywhere. So maybe that there is no sort of localized pattern, but maybe on some of these other variables there is. And that's what we want to do inside a GIS, is we want to look at patterns, relationships, trends. And you students out there, sometimes you might not have a spatial pattern. And don't think, well, my data is not valid or it's not a valid study. This is real world data. You might not have a spatial pattern, and sometimes that's just as interesting, that's just as informative or important as if you do have a spatial pattern, right? So here's an example of a result of an analysis inside ArcGIS Online with these overlay operations that I briefly mentioned, where we have the major geologic hazards, which are these sort of tannish, brownish areas, and then these floodplains, and then I buffered the floodplains by 200 meters, so additional areas. The reason why is because this is Boulder, Colorado, where we actually had like a 200-year flood about 4 years ago. And I wanted to figure out, based on where the geologic hazards were and areas where also geologic hazards in Colorado are mostly landslides, and mud flows. And also...
Joseph, is this Collins where Kokoraz was...
Oh yeah, we use that data for sure. They're up in Fort Collins. Yeah, this is just down the road. And there's been some major floods in Fort Collins as well. And that Kokoraz, I'm glad you used that data because they're on the cutting edge of this. They're great people, great data. So these areas outlined in black are in the major geologic hazards, but they're also in these major these floodplains as well. So this is just done figuring out which areas are prone to two different kinds of hazards in a certain county. And that's just done, again, with overlay tools and buffer tools inside ArcGIS Online. So that's just one real-world example. All right, so touching on what we talked about earlier, story maps, there are various ways of communicating with maps. There's something called the presentation mode in ArcGIS Online. There's story maps, and there's also embedding the maps and apps and web pages, presentation tools like Prezi, or in this case, Sway, and in other forms. You saw how I embedded my web map inside this presentation, remember, with Redlands, California, and light poles and tree species. So that's just an example of number 3. So the presentation mode, what does that look like? Let's just briefly look at that. Don't overthink this, folks. It's just basically taking your web maps, and you've got some titles, and you've got the ability to go from screen to screen. So in this case, this is one of my favorite topics, and this is the importance of GIS in education and society. So in this case, I've got a web map, and then I've got some other maps with my different points. You see what I mean here? So I can skip between different slides. I hesitate to call them slides because they're all tied to live maps. But the point is that you can use this as your presentation tool. And as you can see, at any time, I can go to, for example, your part of the world and look at things, okay? And I'm still in my slide. I'm still in my presentation. Does that make sense? Yeah. So, okay, that's one method. Another method is a set of web mapping applications, including story maps. And I invite you to check out some of these. This one on Lakota language, this is a one that uses audio that I created with a colleague of mine to look at the names on the landscape in terms of landforms in English and in Lakota. So anyway, lots of options for you right there. You can also embed, here's one on urban bears in Anchorage that you might find interesting because the videos of on that story map are actually videos that are from collared grizzly bears. and you know, you can see some of the interesting bear behavior as they cross roads, as they swim, as they, you know, do their thing. So it's a really neat example of multimedia in a story map. All right. So here's a geeky picture of me out in the middle of nowhere. Here is my contact information, some of the resources we talked about, ArcGIS Online, story maps, the nonprofit program, the videos. Does anybody have any comments, questions, concerns, complaints? I know we've kind of looked at a lot of different things today, but I hope that was of interest, not just for this class, but beyond.
What do you want to ask? What do you want to know what he's seen, or examples of things, or impacts?
You are getting very sleepy. Watch my fingers. No, I salute what you're doing. Yeah, and happy to chat with you about any of these topics just now and in the future.
Well, that's something. Go ahead.
Yeah. So I'm more familiar with using the licensed version of ArcGIS. So I guess I'm just curious, like, what the advantages and disadvantages of using the licensed version versus the online. And, like,
yeah, when you say the licensed version, you mean inside ArcMap or ArcGIS Pro on the desktop. Is that what you mean by that?
Mm-hmm.
Okay.
Yeah.
Like a lot of tools, GIS has evolved into, you know, partly a cloud-based, web-based service, right? So just like music, right? You've got some music locally and you've got some music online. Your documents, you've got some locally on your devices there in class, and you also have stuff in Dropbox and OneDrive and Google Drive, correct? So same thing with GIS. So in terms of Esri GIS, which admittedly is not the only GIS out there, but in terms of that platform, it's ArcGIS. There's a desktop app called ArcGIS Pro. There's also ArcMap. There's an online component called ArcGIS Online. There's also a mobile component using Survey 123 and Collector and things like that, those mobile apps. So all three of these things work together. They're all part of the platform, this ArcGIS platform. In terms of advantages to, you know, using your desktop tools versus online, you know, it just depends on what you want to accomplish. There are good things about using desktop, but even desktop nowadays is not just local data and content. It's actually tied to the online environment. So when you do geocoding, for example, you're using an online service. When you share your desktop results of your analysis, you can share it to ArcGIS Online. And then the advantage there is that you can have other people look at your data, right? That was always one of the challenges of GIS, is that, you know, you would work on your project, I'd work on mine, and it was really hard for us to share data and content and models, spatial data models and procedures, workflows, etc. Online doesn't solve all of those problems. There are still organizational barriers, I admit, but it's a lot easier to share content nowadays and procedures and workflows because of the online platform. So I would just say, you know, look into using some of this stuff in ArcGIS Online. You have an account at your university for ArcGIS Online. There are some things you can do in it without logging in. Like you can go out to ArcGIS Online right now, and you can look at, for example, right here, I'm going down to ArcGIS Online. So you can go to map and actually start looking at, you know, historical tornadoes in New York. You can look at water quality. You can look at median age, etc. So you can modify the map and add data and look at, for example, median age. You're not logged in, right? I'm looking at median age right now, and I'm not logged in, right? So interesting. So, but logging in will let you save, it'll let you share. So actually, it's good to know that you can do some things without logging in, but there's a lot more you can do logged in. So this is ArcGIS Online. Yeah, good question. Valid ways of furthering your GIS education. So I'd look into both, you know, desktop and online.
I can't remember if I've said to them before, we've worked to have a server on campus. So we actually have, you can do a lot with logging in an online account, and that even gives us more, having our own server gives us a little more flexibility.
Oh, yeah, good point. All right, folks. Well, I really appreciate you folks taking this course. Again, I think it's an important one, and I salute you, and I just wish you all the best in your educational journey. Again, if I can be of any help to you in the future, feel free to get in touch.
And thank you so much. Oh, go ahead, Joseph. Sorry, I didn't mean to cut you off.
Thanks, Professor McKinster. Keep up the good work that you're doing, sir.
No, thanks. It's always great to see you. I'm glad this gave us a good reason to connect, and I'll send you some of the ideas I had. I posted all the links for the tools and particular projects you talked about in our Canvas site, so you'll have those there, and then we'll get this presentation and the Sway link up online. So we'll let you know if we need anything.
All right, folks. Take care. Have a great day.
Thanks, Ken.
Be social.